e to the u plus c. Okay, these derivative ones are actually easier than the natural logarithmic function ones. And so what I'm going to do here in the very first one is I'm going to let u equal the exponent right here. Okay. What is the derivative of that?
3.
3. And so what I need to do is I need to have a 3 inside, which means I need to have a 1/3 outside. Now, on the next step, this is one that most of you will probably eliminate. I'm just going to go ahead and write them down. Basically, I end up having e to the u times du. Okay? Because I have e to the 3x plus 1, which is u, and then 3 dx, which is du. And so now the integral of e to the u is just e to the u, as it says up here. So basically my answer is 1/3 e to the 3x plus 1 plus c. And there you go.
Couldn't we do this minus the c?
Do you have that in your notes?
Yeah, it's just not the same problem.
Okay, so let's go ahead and look at this one.
That was difficult.
That's the derivative. That's different. This is
You just do the same thing?
yeah, pretty much. The e's are nice. They're the same.
That's nice.
All right, so let's go ahead and look at this one. This says 5x e to the negative x squared dx. So in this case, you've got an e. So you're going to let u equal what?
The exponent.
Negative x.
The negative x squared. So du is negative 2x dx. And so if you look at that, I don't have a negative 2x, I actually have a 5x. And so what I need to do is I need to change that to a negative 2. So I'm going to go ahead and put a negative 2. And then I need to get rid of that 5. So I'm going to divide by 5. So basically it's the same as multiplying by negative 2/5. Outside will be negative 5/2. So once again, I've got negative 5/2. The integral of this will be what, folks? E to the negative x squared plus c. And there you go.
You can get rid of the 5. Oh, because that was
Okay. So far so good? Let's go ahead and look at this one. This one is a little different, but not much. We're still going to do a lot of the same things. So what do you think you're going to do?
u equals x squared.
U equals,
X to negative 7.
how about 1 over x? Which is really x to the negative 1. Du then is
Negative x.
negative 1x to the negative 2nd, which is the same as negative 1 over x squared. So if you notice, really what I'm missing is what? A negative sign. So I'm going to put negative in and a negative out. So what will my final answer look like? Perfect. Good job. So that one actually looked a little more difficult, but it turned out to be fairly easy when we went through it.
So is u always e power?
When you got an E, 9 times out of 10 it is. There is a chance when it is not that, and we will look at that. That comes with like chapter 7. That's with integration by parts.
What happens if there's
And we
two
will,
e's?
we'll talk about things like that. Okay. So that will be coming later, but for right now you should be able to handle your problems with the techniques I'm giving you. So here, what are you going to do? Yep. Okay, so u is cosine x. What's the derivative of cosine?
Negative something.
negative sign. So what do I need? I need a negative sign in and a negative sign out. So what will my answer be? Questions? So now this one is actually a definite integral. We're going to let u equal negative x. du is negative 1 dx. So I need a negative in and a negative out. So what will that integrate to be? And I'm going to evaluate that from 1 to 0. So then now what I'm going to do is I'm going to go ahead and just plug in 1. So I get negative e to the negative first minus negative e to the 0 power. Now real quick, let's go ahead and review. What does that negative 1 mean? It just basically means 1 over e, right? Because that's what the e to the negative 1 means. Here I've got two negatives that make a positive. What is anything to the 0 power?
1.
1. So that would be your answer.
Oh, you don't solve it?
Now you in fact could probably plug that in, but this would be just as fast.
How does that first one go to 1 over e?
Because it's no different than if I had x to the negative 1. If I had x to the negative 1, that'd be 1 over x. E to the negative 1 is the same. It's just going to be 1 over e. And then you have the negative sign in front. Alrighty, let's go ahead and look at this one.
Whoa.
So now, as you're writing that down, I want you to think to yourself, what should I do in this problem? And
U, I think still x, because there's 2.
What do you
X. I think U is x.
now, if you do the u as x, you're going to end up with, so let's just see, you'd have like e to the u over 1 plus e to the u. So then how do you integrate that? Can't. Okay, so then you said the bunny ears. The problem is the bunny ears works when it would be written this way. The bunny ears work when you have one denominator, not two terms in there. Ah, let's try that. 1 plus e to the x. What's the derivative of 1?
0.
0. What's the derivative of e to the x?
X.
X.
X over 1 over.
Okay, what? Okay, whoa, we're guessing now. What is the derivative of e to the x?
2, or it's just e.
It's just what?
E.
E to the x.
What?
Okay. If you remember, the derivative of e to the x is just e to the x.
Why?
The integral of e to the x is e to the x. They're the same things. And so here, with the derivative here being the, I end up having du over u. So now I need to think back to my integration rules. What will du, yep, ln of the absolute value of u, which is actually going to be
1 plus e to the x.
ln of 1 plus e to the x. Oops, I forgot to put the 1. There we go. And we're going to evaluate that from 1 to 0. Now you're probably wondering, why didn't I put the 1 and 0 up here? And the reason is because that was written in terms of u. And so if you remember, we don't write things there unless we substitute those in. So let's go ahead and substitute 1 in. So here I get natural log. When I plug 1 in here, I get the absolute value of 1 plus e. Minus natural log of 1 plus e to the 0 power, which is 1. So really your final answer will be natural log of 1 plus e minus natural log of 2. And there you go. You can actually leave that. Oops. You can actually leave that as it is. If you wanted to, you could even write it as this. We'll see if you understand where that came from. You can even write it as that as well. Okay, because remember when you subtract 2 natural logs? Okay, questions? Okay, you now should be able to finish the integration problems from the assignment I gave you like last Thursday, Friday on your homework.
Okay, but so if it asks for the derivative